Hello, this is Navid Iqbal, and I am going to deliver the lectures on some topics of the engineering geology. First of all, before we go into the details of this subject, we need to know the definition of the word or the meaning of the word geology. Actually, this is the derived from the Greek word geo, meaning earth, and logos, meaning science. Hence, it's an earth science which deals with its study as a planet. That's we can say that in this subject, the study of Earth as a whole takes place. It's a scientific study dealing with the origin, age, and the structure of the Earth. It also deals with the surface, whatever lies on the surface of the Earth, and the subsurface, below the surface, and physical features like mountains, plateaus, plains, valleys, and the materials making up the Earth. The interaction of the atmosphere, lithosphere, and the hydrosphere, including the process involved and the results produced due to such interaction, also fall in the domain of the geology. Geology is a vast subject and is considered as one of the fundamental basic sciences like physics, chemistry, and biology. Here, we will restrict our study to the engineering geology only. Engineering geology may be defined as that branch of applied sciences which deals with the application of the geology for a safe, stable, and economic design and construction of civil engineering project. For any construction to take place, a civil engineering should know the planning, the designing, and the execution for the erection of the structure. So, for a civil engineer, fundamentals of engineering geology is very essential as that of other subjects like soil mechanics, strength of materials, etc. Because application of geological knowledge in planning, designing, and construction of big civil engineering projects is very essential. So that's why this engineering geology subject is taught in this civil engineering curriculum. Now there are the two reasons why we study engineering geology. First is to understand the geological nature of the construction site. That's it enables the civil engineer to understand the engineering implications of certain conditions related to the construction area, whether it's a bridge site, tunnel site, or any other building site. Another is it enables the geologists to understand the nature of the geological formation for the safe design and construction of the civil engineering project. For example, road or a railway tunnel site analysis is done by the geologist to make sure its feasibility. Now, the first topic of this subject is the geological work of the natural agencies. Geological work means the work carried by the natural agencies like rivers, wind, glaciers, etc., in modifying the physical features existing on the Earth's surface. Physical features means the topography of the Earth. For instance, if we take the example of a stream, it carries tons of sediments from its origin to the sea. This enormous load is brought from the slopes of the valleys and from the base of the channels. These sediments are carried by the river because of its kinetic energy possessed by virtue of its velocity. Glacier also carries an enormous amount of load with it during its motion along the mountainous slope. It is also because of when a glacier is a large mass of ice, when it moves, it carries with it the sediments, the rock particles from one place to another. The work of the natural agencies may be either constructive or destructive in nature. That's at one place the natural agency erodes the material from the earth's surface and deepens it. Hence, we can say that it is destructive at that place. On the other hand, this material is deposited at some place, creating alluvial plains, flood plains, and deltas. This is the constructive aspect of these rivers. The agencies, these natural agencies which are responsible for the geological change on the surface of the earth, they operate ceaselessly. They don't have any limits. They operate ceaselessly at places individually, or they can they can take place in the close cooperation with one another. Almost all the physical features existing on the earth at present. For example, we can see the mountains, the plateaus, the plains, valleys, and basins. The shape that they exhibit today, it is all because of the creative or modifying work of these agencies through geological ages. These are some of the terms that are related to the engineering geology. These are weathering, erosion, and denudation. These will be described in detail in the next slides. Weathering. It is defined as the process of decay and disintegration of the rocks under the natural agencies. The weathered product, it may remain either at or near the parent rock. Now, what is the reason why these rocks get disintegrated? This phenomena, this thing will be discussed in the next slides. For example, rocks exposed to the frost action in higher altitudes disintegrate into small sized fragments. Similarly, rocks exposed to heating temperature of the sun in deserts gradually disintegrate into smaller pieces. The reason behind it will be discussed in the coming slides. Now the next topic is the different types of weathering. Actually, there are two types of weathering. One is mechanical weathering, another is chemical weathering. Mechanical weathering is the process of disintegration of the larger rock masses into smaller fragments and particles through physical process without any change in their composition. That is, whatever is the composition of the parent rock, same remains in the disintegrated material. These weathered particles may remain on the surface of the rock if it is plain, or may get accumulated at the base because of the slope. These rock particles roll down under the influence of the gravity. Now there are two reasons which are responsible for the extensive mechanical weathering. One is temperature variation, another is organic activity. Though organic activity does not contribute to much to the mechanical weathering, but temperature variation is held responsible for extensive mechanical weathering of the rocks exposed on the surface. It is responsible for weathering. This temperature variation is responsible for the weathering in two ways. One is frost action, and another is thermal effects. As we know, water on freezing undergoes an increase in its volume by about 10%. In intense cold regions, water gets accumulated in the pores or fissures of the rocks, we may say in the cracks of the rocks. Because of the extensive cooling, this water gets frozen. When on freezing, this water, as we know that its volume changes, it creates an additional pressure on the rocks, because of which these cracks they widen, and more water gets accumulated in these cracks. Now, when this water in the cracks it expands, it creates a freezing, because of which the volume it expands, it creates a pressure on the rock, and when this frozen water, when this melts, this is known as thawing. This freezing and thawing creates an internal stresses leading to the disintegration of the rocks. Now another effect responsible for the mechanical weathering is the thermal effects. As we know, in some areas where there is a large variation in the day and night temperature, because of which these rocks when they get heated, they expand, but when on cooling they suddenly contract. Because of this expansion and contraction because of this expansion and contraction, the internal stresses are created, because of which they develop cracks on the surface of the rocks. There's another process which is known as Unloading. Unloading may be defined as the due to the prolonged erosional work of the natural agencies, the overlying rock cover gets removed, because of which they expand upwards but remain confined from the sides. When the erosional work is performed by these agencies, the top layer of these rocks is removed. These rocks, although they are remain confined from the sides, they expand upwards. Consequently, joints develop in them parallel to the uncovered surface, dividing them into sheets. They are divided into sheets. This rupturing or jointing in itself is a mechanical breakdown of the rocks. When these ruptures take place, this is the mechanical disintegration or breakdown of the rocks and makes them available for the further weathering along the joint planes. This whole phenomena is known as unloading.